Hey again, guys, and welcome back. Some of you may have remembered the doorbell project that I had a little while ago. Um, it was an attempt I have made, but whenever I had used it a couple of times, maybe every 10th or 15th time, it would actually fry the Arduino inside here. Basically, it's a project that takes it combines a PIR sensor with a microwave sensor, and when both of these are triggered, then it rings a doorbell. So I just got a off-the-shelf wireless doorbell. This is the unit for it. And the way I was doing it is I was activating the wireless chip directly with a transistor, but I've decided that's not the way I want to go anymore because it just was killing Arduinos. Now, a whole bunch of people reached out with really good advice, but I decided to go with what I know and what I understand, which is a relay. And instead of switching this directly, I am going to, I don't know if you heard that, but I'm going to switch the switch directly with a relay. You see, what I like about a relay is that it is a switch, where a transistor is basically a switch, but it has a voltage drop associated with it, and you also need to make sure that the base is above the emitter voltage and stuff like that. The relay really doesn't have any of those limitations. It's literally a contact flipping over, and it's just as if you flipped a switch. So I've modified these boards here via PCBWay to make this board. So it'll use much of the same components. It'll use the same kind of wiring. It'll use same sort of LEDs to show that it's working or not. It still uses the same 6 to 16 volt in, but now it will use this relay module here on these holes, and that should be all I need to get this working, and working flawlessly for a long time to come. I'll even make it so that the end user can disconnect this and replace this relay. I think repairability is a big deal, especially when this is going to be deployed in the field, and so that is what I plan to do. Let's put one together. Alright, first things first is I did put some SMD pads here for optional resistors and LEDs. I personally am a big fan of SMD parts because they take so little space up on the board, but I do realize that some of you people might have issues soldering to them. So what I'm going to do, I think, in the future is I'm going to make them optional through hole or SMD. Let me know in the comments if you're okay with SMD, or if you really rather through hole in my designs. I think honestly SMD is not that difficult, as I sit here struggling to try to get an LED into position. But obviously make sure to tell me if that's a problem for you. So just trying to get this LED in the spot. Oh, I did it again. So what happens is sometimes the LED floats a bit if you don't hold it down properly. There we go. Alright, so that one's there. And then this one here. And now I am using a 4.7k ohm resistor, and I believe that these are red LEDs. And I'm using a 4.7k ohm because I want them to be dim. Basically, since this box is transparent, I don't want it to scare the bejesus out of the mailman. And so, yeah, this is just for diagnostic purposes only, basically. So there we go. I put a little K on the board. That's the cathode of the LED. So here we go. Now, of course, I'm hand soldering all of this, which is why I feel like 0805 sized SMD parts are really not that bad. You can hand solder them. But if it makes you feel any better, I think it's only $10 for a stencil from PCBWay. Oops. And of course, this is way easier to solder when the camera isn't in the way. And there we go. I'm just going to test it real quick, just to make sure that they'll work. So this is 5 volts. I think it goes like so. Yep, see? Dim little LED, which is good. And yep, dim little LED. Perfect. Next thing is I want to do the Digispark itself. So the Digisparks, they have the pin headers on them, but I cut some female headers up. And basically I want the Digispark to sit in headers, again for repairability. So it can be removed, replaced, etc. So just going to do this here. And in order to support it, I'm just going to put another Digispark on the other side. Sort of in there. There we go. And as soon as we get it tacked down, it should be good to go. Oh, gotta hurry up. I want to overheat those pins. The Digispark also is going to function as our 5-volt regulator. And that should be good. Flip this over. And yeah, it's a little crooked, but the point is, Digispark easily goes in and out of that. So that's pretty good. Next thing is I'm going to set up some bolts and stuff to get our relay mounted up here. So to mount this relay here, I've got the footprint there, and I think what I'm going to use is these nylon spacers. So I'm just going to install those, and then what it'll let me do is use these nylon screws through the bottom. In fact, you can use metal screws. This is just all ground plane on this side, but it just I so happen to have these nylon parts, and I believe they are cheaper than their metal alternatives. So I'm going to use the nylon. These nylon standoffs and stuff, they were actually meant for building drones, but you know, haven't built a drone in a long time. So then you also have a negative, positive signal and ground 5-volt signal on the board. So I'm just going to put a little extension lead on there momentarily, and that will plug in. Again, the point here, because this is going to be deployed at someone's house, is going to be repairability. So this person has to be able to fix this board, you know, with just, you know, with me showing them how to maybe, but they have to be relatively able to fix their own stuff, and that's the thought process I'm using here. In fact, I typically socket things anyways because I feel like I might want to reuse parts in the future. So, I mean, it's kind of the same philosophy, right? To get something that's repairable is the same thing as being frugal and reusing parts, even though so far I haven't gone pillaging for parts. So that should be in there. And I haven't test fit this in a while, so just want to make sure it fits. So there's the box it's going to be in. That goes in there. And then this goes in here. So yeah, there's tons of room in there. And you can see the LEDs. Everything is good. Alright, next step is going to be to put my 2 extension leads. And in fact, I've got some here, so I might try to remove these from this board off camera and then install them onto here. Alright, so I'm going to connect the relay onto the board here. I'm going to use these servo extensions, and now you see ground, 5 volts, and signal. Well, brown, red, and orange, so that works perfect, and it's the exact same on these here, so that'll fit here like so. And then I want to, trim a little bit off and just solder that directly onto here. Now I could use pin headers, but this doesn't need to be serviced. This does. So I think what I'm going to do is I'm just going to chop off a little bit here like this. Now you can crimp your own one of these connectors, but I just figure these RC ones are already pre-made. So I'm just going to gently try to strip off the insulation here. Sorry, I guess I should do this on camera. Then I'm going to fold them to each their sides, and so I can twist all the little stray strands together. And then, now if you're not comfortable with your soldering iron, and you're not skilled with your soldering iron, or if you're not a glutton for punishment like me, you can just stuff these wires into these holes and be done with it. But I think to make it easier to solder once it's in there, I'm just going to pre-tin. Just want to hold that down somewhere. I just want to pre-tin these ends here, and you got to be careful because if you put a giant glob of solder, it's never going to go through those holes. So you just got to be careful, and you just put a little bit, and then I do like a wiping action to get it off, sort of like that, because I just want the strands to all stay put, and at the same time it pre-tins just a little bit, so that when I put it through the holes, then I just have to touch it with the soldering iron. I'm just going to rearrange them now, be a bit more straight, and then just make sure ground, 5 volts, and the signal. And if you didn't put too much solder onto these wires, should be now able to just feed it through, and it'll be good to go. And then all we'll have to do is just touch it with the iron on the back side, and it should solder. Alright, so that's in. Alright, should just have to touch it with the iron. Maybe we bring in a little bit of fresh solder. That one's done. That one's done. And that one's done. So there we go. Got a little bit too much sticking out. We're just going to trim it. There we go. Hopefully that didn't fly into my coffee. And then ground is still indeed brown. pop this in like this, and then this should still fit in that box, sort of like that. So the next thing left to do is to program the Arduinos, and then give it a test. Oh wait, one more thing we have to do after that. Run the wires into here. But the Arduino program should be pretty simple. Basically, it should be like if pin 0 is high and pin 1 is high, then pin 2 should be high, else pin 2 should be low. So basically, if both pins are high, then we want to send a high on pin 2, and if not, we want to send a low on pin 2. And then you can even put a delay when you send the high to pin 2. You can shoot it back down to low after a second, and then add a delay. Now I think my client wants the delay to be fairly large, so I think I'm going to go with something like a 5-minute delay, and then it should be good to go after that. So let's program the Arduino and see if the relay clicks. I got the Arduino programmed and plugged in here. Plugged in because I think it has 30 seconds where 30 seconds or a minute where it can't do anything, because I think that's how the bootloader works on this thing. But after that, it should be able to work just fine. I've got 2 jumper wires in the 5-volt section where the sensors would be plugged in, just so we can touch them to my breakout pads here, and so that they can emulate a high signal from both sensors. And if I take this and touch it here, yeah, you see that LED lights up? I don't know if you can see that on your screen. And then if I touch it here, that LED lights up. Okay, you can see that on your screen. So right now, this is not doing anything. But if I touch both, the relay just clicked. Hopefully you heard it. Maybe you saw the little LED there turn on. But yeah, so that worked. It's just that nothing else will happen now because it's locked out for 5 minutes. So I think that works well enough that we can continue on and solder some wires onto here, feed them through the cap, this thing here, to the back, and then plug them in here. So for the switch now, I've got this really thin, I don't know what gauge this is, really small, 30 gauge wire. It doesn't have to carry a lot of current, but it does need to be fairly solid. So this is a silicone wire, and this here is the switch contacts. Now these 2 are on the same side and these 2 are on the same side, so when you press the switch it links these 2 sides together. So I will basically lay wire like this for both sides, and then run it through here, and then put a ferrule, if I have a ferrule small enough, so that the screw terminals don't absolutely wreck this thing. So we're going to do one at a time. I'm not sure how long of wire I want to put in. I want to put in a reasonable length because, again, serviceability, you do need to pull this apart to swap the batteries, for example. So I do want to put in enough length for that. But I also know that I don't want too much length to crowd the housing. Oops. Seems like I'm grounding it. Oops, I pulled that too early. Okay, that should hold. Alright. What's a reasonable length? Maybe that long? Something like that. And then I'll cut these in half after. Actually, I need to cut it in half now because or else it'll just keep beeping at me. So let's say that length. Okay, and then tin that end too. Like so. Mind you, I can also just tin the end. I don't really need to put a ferrule, but I mean, if I have a ferrule that fits, I will use it. Push that in there, let it solidify. Okay, and now that should be pretty good, and then that should fit through this hole here. Now I've got glue covering the entire hole. Don't know if you can see that. So I'm not concerned about it being waterproof, but I do have a hole in the base of this whole thing so that, you know, water, if it does get in, which seems like it kind of has to at some point, then it'll drain out. So there we go. That shuts really well. So I got my wires coming out here. And yeah, again, I gave myself quite a bit of length, but that's okay. I'm gonna just chop it to the same length, and then I will take off this insulation and then see if I can find a ferrule small enough to fit this. So I did find some you know, these ferrules. Don't know if you can hear that, but it is activating the doorbell. And I also have one of the Arduinos plugged in, so we can try to set this up and see if it'll ring the doorbell when we jumper on these. Okay, well, so one of these shouldn't trigger it. Okay, not triggering it. The other one either. Nope, but both together should trigger the doorbell. It works. It works just perfectly. So all that's really needed now is to put these two halves together, mount it into the little box, and send it away. And so really there's not much else to say. This is the completed project. Now the person that commissioned this will have to run a wire through here, solder to positive and ground here, which will power the Arduino, and then this little 5-volt regulator will power you know, the chip and this relay, but the relay is only on for 500 milliseconds. Now I'd really like to show you this in action, but unfortunately it locks out for 5 minutes after every time it triggers, and if I wait 5 minutes and then hit record, just the act of hitting record will re-trigger it, so I can't really get it on camera, but this is basically what it looks like. And when you shut this box is completely waterproof, except that I drilled a hole in the bottom for his wire to come up and over. At the same time, that hole right down there will be the breather hole for any moisture that does come in. It should run down into there. So none of the components should be, you know, hit by actual rain, but humidity is a thing, and so I find it's best to just let your stuff vent out instead of trying to make it completely waterproof. But if he wants to try, he can always put a little bit of glue or something in there. So yeah, this is enough for me. Let me know what you think about the project. Is something like this useful for you? Do you want a doorbell that rings itself? I know personally I want to get rid of annoyances in my life, but I think what's happening with this person is that the mailman or whatever is coming by and just not ringing the doorbell, so packages just stay outside this person's house forever, and that would be a bad thing. So yeah, I guess if that was happening to me, I'd want one of these too. But yeah, if you want one, go down in the comments or in the description, and you can get the Gerber files and have them made. These boards are small enough that they are within the $5 confines of PCBWay, and so you can order some and have a look. Thanks for watching.